Okay, so I'm going to share my screen again. So thank you for the opportunity. First, let me apologize for a couple of things. One of those is that amongst this fabulous meeting, this will be one of the most boring presentations because it is a presentation, not a hands-on practical idea, just sharing some ideas about what we do. It's more about thinking about what we do with our students instead of actually doing with the students. That doesn't mean that I don't do, of course. The second thing is I'm not a native English speaker, so if I destroy your language too much, please feel free to point me out. I will try not to mangle too much my English. Okay, so I'm going to start now. I really hate to do presentations as in PowerPoint mode, but in this kind of situations, it's what we have to do, So I'm here to talk to you about the link between, you can see all the presentation? Or is anything blocking the screen? Okay, just going to shift my Zoom square over here so that everything can be seen. So basically the idea is to share some thoughts about the connection between computational thinking and 3D modeling and printing, because before getting into it, just let me tell you a few things about myself. As you may know, I'm an ICT teacher from Portugal, but one of the secrets of my career is that I'm actually an arts teacher, but teaching ICT, and I try to connect ICT teaching with arts and crafts, trying to work with code and with robotics, with 3D, of course, but always trying that my students go beyond just learning a coding language, do a game, etc., but also try to be creative, to actually be creative and use technology for their own personal expression, to express their ideas and to be artistically creative, which is not something that is very usual in ICT class in Portugal. So first and foremost, everything I'm going to speak to you comes from my practice as a teacher. So I try to mix, as I've said before in my classroom, creativity, digital tools, art. Of course, they have also to teach the curricula of ICT class, obviously, but we can do it in more fun ways. What I'm sharing with you comes from the field. It means that it's my experience, my personal experience as a teacher. And just to be clear, I've been working with 3D and students and children. I teach about 10 to 12 years old in Portugal since about 2005. So it's a long time doing this with kids. And lastly, I'm not going to speak too much about this, but I also try to use a lot of mobile devices creative tools. At the start of this conference, there was a comment on the comment session about kids nowadays seem to love their phones. Well, I love my phone also, and I really like to try to bring our phones, their phones, my phones into the classroom and make them do fun things with the phones, like coding, like 3D, etc. Because we can do that, because a mobile phone can be so much more than just being a conduit for TikTok videos and WhatsApp messages. They can create stuff with a powerful computational device that fits in their pocket. So before getting into how to foster computational thinking with 3D modeling and printing, let me just give you a few. I know I assume I'm speaking to teachers, so they must know about the concepts of computational thinking. But I'm just going to do a brief overview of these ideas. First and foremost is the work of Janet Wing, which defined very acutely and very intelligently the concept of computational thinking, the idea that we can apply thinking modes and structures from computational sciences into education, into our own lives. But before that, before Janet Wing created the main tenets of computational thinking, there was the work, for example, of David Jonathan that spoke about using computers as cognitive tools, using even basic, for us, tools such as office tools can be enablers and fosterers of advanced cognitive skills in our students. But for me, the absolute giant is the work of Seymour Papert, which I'm sure all of you have heard of it. because for me, the most outstanding insight of Pappert's work is this idea that learning to code, learning using computers can be a path for a deeper, for a more personalized level, for more cognitive approaches in education. And also his idea that we can and should give our students environments that are low floor, high ceiling. I really love this expression because it encompasses, encapsulates such a wide philosophy, as in give students something that is very easy to start with, but then does not seem to be to have an end in itself, and they can always progress more and do more and create more. That's an outstanding idea, which I believe supports the very best educational platforms and the very best educational digital environments. So, picking up on the idea of computational thinking, there are some tenets, some basic ideas and concepts that framework this approach. Of course, the idea is not to think like computers. Is everything we always say that when we are talking about computational thinking, we don't want to think like a computer. We want to understand how can ideas from computation can be applied for your life, for your other projects, etc. So, how can all these be related to 3D modeling and printing, etc.? Well, you see, I'm just going to step back a bit. All these concepts of computational thinking, logic, algorithmics, decomposition, pattern recognition, abstraction, evaluation, etc., we ICT teachers like to work with them using, of course, coding tools and robotics tools. But we also say a lot that computational thinking can be far more than that. We can go to our own personal lives. For example, every time we teach our students, our 5, 10-year-olds, about what is an algorithm, we always choose what is significant in their lives, how to bake a cake, how to do something simple, and from that example, explore the concept of algorithms. So if computational thinking is so transversal, can be applied in multiple contexts, the idea is, why should we not look at other types of projects that we do with our students and try to understand if we can use them in computational thinking settings? I'm not saying that we have to turn everything into computational thinking. It's just another very interesting pedagogical approach, but we can see if some other things that we used to do in other areas can actually have CT, computational thinking approaches possible. So, one of the very first concept of computational thinking is the idea of abstraction. And from then on, we have to think every time a child or a student, or even some of us, has to create something in 3D, the very first thing that they have to do is to create a mental concept, to inside their minds, inside their head, in their brains, visualize their modeling, what they have to do. So I believe that this is the connection between the abstraction idea of computational thinking and how you can use 3D to foster it. As in, okay, you want to model a car, you want to model a plane, you want to model a house. First thing you have to do is to think about it. What do you really want to do? And by thinking, we are abstracting, of course. Another concept of computational thinking is the idea of developing algorithms. And that, I believe, is tightly joined to the practical way to create, to model. When I'm creating a model, which are the steps which I take to develop and to create? Which tools do I use? Which sequences? Which are the steps I have to take in order to get to my destination, which is to create a 3D object. So another concept of computational thinking is the idea of logic. And this is something that is pervasive, because every time we are creating something, either be a drawing, writing something, we are always analyzing what we do. Is it working? In the case of 3D modeling, are my steps effective? What I'm doing is getting the results that I want to, or is it not getting it? Of course, this is connected to the idea of evaluation, because all these concepts are not isolated; they work between themselves. Actually, this was the concept that first made me aware that that 3D modeling in education could be a very nice way to foster computational thinking skills, which is the idea of decomposition, which computational thinkers always describe as break the whole into parts. You have a big problem, so instead of focusing and getting scared of a big problem, just break it up into small problems, tackle each one, and then at the end of the process, you have your big problem solved, or at least in the process of. So, and that's actually something pretty obvious when you are doing 3D, because when you are doing 3D modeling, we have to think about what we need to decompose. We have to look, if for example, if we are recreating a model, for example, of a human being, we have to think about what makes a human being. How many arms, how many legs, how many faces, just one generally, but of course. But and we have to decompose, we have to look at the whole and focus and decide what is essential, what is not, what makes the object. I'm not using a pencil for example of this connection as a random example. It's just one of the projects I use with my students to make this more clear. Another interesting concept of computational thinking is the idea of pattern recognition. Look at your problems, look at what you have to solve, either in coding or in other areas of your life, and see the pattern. And in 3D modeling, this is extremely obvious. The most easy way to explain this is if you have to model a building, a house full of windows, do you have to model one window and then duplicate it, or do you have to explicitly model each and every window? Of course, the answer is obvious. I just have to model one and then duplicate and replicate as needed. And that's pattern recognition. It's looking at something that I'm creating and thinking, evaluating, understanding what should I focus on, what is really important, and what can be duplicated. And of course, evaluation. It's another transversal concept, and it happens in every stage of computational thinking, because in 3D is exactly thinking what I am doing is working. Is it accurate? Does it fit with what I had in mind originally? Am I improving about my modeling process? Am I improving about my original project? Am I not? Because of course, evaluation is about understanding what goes right, what goes wrong. If it goes right, how can I make it better? If it goes wrong, how can I try to make it better? And of course, as always, never give up. So another thing that 3D modeling and computational thinking, this connection allows, is to work with learn by doing settings, because the kids that are working and creating their models, their objects, their toys, whatever, they're not actually thinking hard about the concepts of creating an algorithm, of logically analyzing, etc., and pattern recognitions. They are just creating things, and they are retrying, and every time they encounter a problem, we just have to show them, don't worry, debug it. What's wrong? Don't, and especially be resilient. Don't give up. It may seem hard when you start, hard at the beginning, but don't give up. Keep working. Every time we may give some little help if they need, of course, obviously, but always, instead of showing the student the path, just give them a little nudge, make them overcome their small bugs, and they'll do the rest by themselves, because this also has to foster their own inner learning and their own advanced cognitive abilities. So actually, how to make this? Well, of course, I've been working with 3D and teaching 3D to my students for a long time, way before I've come into contact of the idea of computational thinking. But nowadays, when I'm teaching 3D modeling to my students, what I try to do is to make all these concepts as clear as possible. As in, when they are starting to learn how to use a 3D modeling software, instead of just learning the basics, I always try to challenge them to create a small project, like a small animal, a small ghost, a pencil, whatever, that allows us, all of us, in the huge of course I teach 28 to 30 students at a time, so I think it's huge in a large classroom setting to explore the ideas. If you want to model a bird, how do you decompose it? If you are using primitive modeling, which shapes do you have to use in order to describe and to recreate the object that you want to model in 3D? From my experience, this kind of approaches works in small children, of course, works best using the primitive modeling techniques. As you may well know, primitive modeling is about picking 3D shapes and then combining into more complex shapes. And 3D modeling with primitive modeling is actually, how can I say it, a way of thinking. I actually had this insight a couple of years ago at Little Maker Fair when I was talking with an engineering student, also a big fan of 3D modeling. That's at the middle of conversation just told me, you know, when I started to model in 3D, I began to look at the world and to, in my mind, to try to recreate the world using the 3D shapes. And I was talking to him and understanding, and I was like, I'm just like you. This becomes a process that is far more than just using a tool. It helps us to understand and to see the world in different ways. You may see that all my examples come from mobile phones because I do try to foster different use for mobile phones than just being appliances for consuming information. But of course, any application, Tinkercad is of course maybe the one you know best, that allows you to do 3D modeling and printing using primitive shapes is actually one of the most useful tools. But any tool that allows you to do this can be put in the hands of our students, and just let them run with it. They always surprise you in ways that you never expect. And of course, if you have access to 3D printers, which in this club to which I'm talking about, maybe everyone, it gives them an extra edge, because you all know this. The first time a student picks up his first 3D printed project, his first object that he, in his mind, with all his creativity, developed and created and worked hard at it in the screen. But the screen is fun, but the screen is two-dimensional. I'm running out of time. Am I running out of time?
You are, sorry. I was like messing with my thing. If you could, like, if you do you want to have a chance for questions? That's what I was going to ask.
Okay, so I'm just going to wrap it up. So
okay, cool.
If you want to do other kinds of modeling using more complex 3D modeling software, again, you can of course connect 3D modeling and computational thinking. Just do this, explore the process, be clear with your students, and of course connect the act of modeling with thinking about something. So these are some of the outcomes that come from my work. The idea of connecting art to SET, the idea that creating 3D is first and foremost a mental challenge, that mobile devices can be awesome creativity tools, and of course, if you say that you can develop computational thinking skills in interdisciplinary settings, sorry, just lost my language over there. You can, why not? So, time for questions. These are the questions I pose myself. Am I relevant? Can I use computational thinking to foster artistic activities? And or am I overgeneralizing, just trying to fit different ideas, etc.? So, if you want to know more, to contact me, I'll just leave my contacts over here. And Alitia, I hope I'm not messing too much your name. I'm finished. So open to all questions that you want.
Okay, if anyone has any questions, feel free to add it in the chat. And if you don't have any questions right now, but maybe something comes up later, after Sarah presents, then we can ask more questions. Okay, so there is a question. I would love to learn more about which mobile tools you find most valuable. think that's a great question.
Okay, so again, back to sharing.
I'll have like 3 more minutes for questions if that's cool.
Okay.
Then I actually think we gained a little bit more time, just so you all know, because we had something else in between that ended up getting canceled.
Okay, the mobile tool I use for 3D is this one. It's 3dc.io. It comes from Estonia. It's an app and also a web application. And I'm just going to show you the inside of it. It's extremely simple, extremely basic. It's not as advanced or as complex as other modeling tools, but it's free. It's for us Europeans, it is important. It's GDPR compliance because my students don't need to give any data to the company to use the tool. And it's actually pretty simple. The problem is it's too simple, but if you are working with 10 years old, this is a perfect tool. And this is the tool that I focus on when I'm working with mobile devices and 3D modeling. If I'm working with mobile devices and other types of computational activities, there are of course other tools for coding, etc. But that's not the scope of what we are talking about here.
I think that's a helpful tool. Oh, okay, so there's another question. What's the best way to handle lessons and workshops where 3D printing takes a lot of time? Our classes can have about 12 kids and I can have them play with the apps, but 2 of the 3D printers couldn't print all of their projects within a 2-hour after school session. I'd love to give them deliverables where there are other options. Maybe to share what you do, and then I am sure that there's probably other folks too who can share different ways that they've set up, but I'm just gonna give you 2 more minutes just so you know.
Counting? Should I put my counter? Okay, so what do I do to survive? Basically, I teach a 1-hour class weekly with a bit more than 12 students. I teach 28 students. So it's impossible to teach 3D printing and have all the projects ready on time. It's completely impossible. So what I do is I focus on teaching 3D in class, and if they want to work outside the class, of course, they are free to do it. And at our school, we have two 3D printers. One is in my office, and the other is in the school library. And every time our students have 3D projects, they send to us. My robotics robotics club kids do the printing, or for example, or sometimes I just print myself and then give it not in the next class, because 3D printing 30 projects takes a long time, but in other classes. Since my office is connected to my classroom, the kids can always enter, interact with me, with the printer, etc. It's rather an open space. That's how I solve my problem of time and, of course, the constraints of technology. There are, of course, many other ways to do it.
Thank you so much for sharing. That was awesome. I didn't even know about a lot of those mobile tools, and I think that's a great way to integrate the use of phones that oftentimes just get pulled out into the lesson. I think that's awesome.